Good morning, all of you, and here is a nice problem which connects area bounded figure with the inverse function and with the Riemann sum. And these problems are perfect for J advanced. So let's start with the problem. This was recently created by me. So f is a function from 0 to 1 to 0 to 1 given by f of x is half times 3x minus x cubed, where gx is f inverse x. We need to find the limit of this function. So remember, we have two important things. G is defined as f inverse x. Now you must be knowing, for a function to be invertible, it must be bijective, in the sense like it has to be 1 1 and on 2 in that particular interval. So let's appreciate that fact first before we go further. So if I'll see the function, it's 3x minus x cubed by 2. So its derivative is going to be 3 minus 3x square over 2. So it's 3 by 2 into 1 minus x square. If I'll see in the interval 0 to 1, which I'm interested, so clearly f dash x is going to be positive, right? Since f dash x is positive, so it's a strictly increasing function. To understand the nature of increase or decrease, whether it is increasing like this or that, so concave up or concave down, we can check the rate at which single derivative increases. Okay, so for example, in the above case, let's say slope was 1 over here, and the slope is slowing down, so it's 0.8. So here double derivative is definitely less than 0 because slope is decreasing as you are approaching increasing in x. Here f double dash x greater than 0. So in 0 to 1 interval, we can clearly sense this will have minus 3x as the slope, which is less than 0 for all x in 0 to 1 interval, which shows the graph of the function is concave down. So hence roughly the plot of this function will be at x equals 0, I'll get 0. At x equals 1, the function value will give me 2 by 2, which is 1. And the function is a bijection in this interval 0 to 1 to 0 to 1. So it's 1 on 2. And hence happily we can find the inverse. Now the problem is, can you really find the inverse of this function? So is it possible to explicitly find g of x? So that will be very difficult over here. Okay, and that is, please don't try it at home because it's going to be extremely technical unless you know some standard method of solving cubic expression, and that's not required, and that's the beauty of this game, of this problem. Okay, so far so good. So we know this is y equal to f of x, and now the inverse function will be nothing but the image or the reflection of this in y equal to x line. So this is f inverse x. We don't care what is this, but roughly we know this will be the image of this. So let's say on the function, if I have some value a comma b, so its image is going to give me a value b comma a over here. What does a comma b means? A comma b means along x direction if I'm moving by a unit, and along y direction by b unit, so it will completely be reversed. Now along x direction I'll be moving by b unit, and along y direction is x unit, right? So if this height is b over here for my function, so clearly on the graph of f of x, the input will be, right? Or I can tell what is a, it is nothing but g of b. So this thing you remember, because g of b means if we have a function f of x, I am sending input a, the g machine will eat this input and it will send back to a as the output. It means if function is eating a is giving b, the g of x will eat a and b will produce a. So a comma b pair is being inverted to b comma a, and that's why the name inherited in inverse function. Okay, so on the function, if I take any point with the height of b, the corresponding to that, the x coordinate on the function f of x is going to be gb. Similarly, if I'll take a height of c, let's say, so the x coordinate is gc, just a language. Why I'm interested in this thing all of a sudden? Because we want g of something minus g of something. So that gives a motivation of producing this distance as g of c minus g of b, provided the point a comma b or a comma c lies in the graph of that function, right? Equipped with these basic tools, now we are ready to hit this problem. So here we go. So we are given a function 0 to 1, output 0 to 1. And now what I am going to do is to divide this interval along the y-axis. The reason I am dividing along y-axis is, let's say if I have a function f of x, so its area of function from 0 to 1 is going to be this area of this region. If I ask you what is the area of its inverse, which means g of x from 0 to 1. So if we have g of x here, from 0 to 1 it will set this area. Now that is exactly same as the area of function f of x from y-axis. Okay, so area bounded by f of x with y-axis, and of course the line y equal to 0 and y equal to 1 is same as area bounded by g of x with x-axis, right? So these things are very crucial geometrically. Now with this, since I want to produce g of something minus g of something, so I'll take a function f of x and we'll divide the interval 0 to 1 into n parts, and here of course n equal parts. The reason being, let's say this point is 1 by n, 2 by n, so we'll have some part k minus 1 over m, the next part is going to be k by n, and so on and so forth, and the last one is n by n. I'm dividing this by taking motivation from the problem itself, because this problem is nothing but simply, if we start playing with the problem, so evaluate this at k equals 1, so we'll have g of 1 by n minus g of 0 by n times 1 by n. Similarly, g of 2 by n minus g of 1 by n times 2 by n, and so on and so forth. So that motivates me to develop the difference of length into width, which is basically area of rectangle. So hence with that motivation, now I can tell corresponding to k by n, I'll get a point, the input, which is nothing but g of k by n, right? Similarly, corresponding to k minus 1 by n, I'll get a point over here. So they are consecutive point, k by n and k minus 1 by n. I'll get a point on the x-axis, which is j of k minus 1. Right, because it's a property from the inverse function that we have got. Now what about this distance? This distance is nothing but g of k by n minus g of k minus 1 over n. Now this time we need to multiply with k over n, and k over n is the height of this function. You can see k over n is this height. So we have basically this height times this distance, and that is nothing but here upper Riemann sum of this rectangle, right? It is a small rectangle. So this small segment represents this small rectangle piece of bounded area between the curve y equal to f of x, y equals 0, and the line x equals g of k minus 1 by n and x equals g of k by n. And now it's not difficult to see, if I sum this area over the entire interval from k equal to 0 to infinity, so this will give nothing but, in discrete sense, k equal to 0 to n if I'll sum it, where n tends to infinity, then this will give the area bounded by the function f of x from 0 to, and that is precisely our problem. So when n is tending to infinity, clearly this a small segment of Riemann sum will tends to 0, because this slice will become to a smaller. So the error that will encounter is tending to 0, and here of course it can be shown, like whether you take k by n or if the question would have been k minus 1 by n, the answer will converge to the same value, right? So it doesn't matter whether the problem is k by n or k minus 1 by n, because the upper Riemann sum and lower Riemann sum will converge to the same value here, because function is an integrable function, it's Riemann integrable here, which means basically it's bounded and continuous. Even if it is discontinuous, still you can use Riemann integration, as we are using with discrete functions like a step function or fraction part of x. Anyway, so that gives you the entire area, and this is my answer to the problem is 0 to 1 f of x dx. And since f of x is already known to us, so that goes to 0 to 1 3x minus x cube divided by 2 dx, which is half times, it's evaluated to 3x square by 2 minus x4 by 4 evaluated at 0 to 1. So we have half 3 by 2 minus 1 by 4, which goes to half, 6 minus 1 5 by 4, and the answer for this beautiful problem is 5 by 8. So I hope you must have enjoyed the problem, and more than just enjoying, you must have understood how geometrically we are able to translate the information of Riemann sum, and geometrically we are also able to relate the inverse function with the original functions. Thank you, have a good day. Please do like and subscribe the channel for more quality content for free use.